lead identification, and content analytics. Generally, how analytics work is that you have a cookie that's placed in your browser and you visit back the same website, it tracks based on the cookies. But what happens is that people delete cookies. They also have systems or extensions or plugins in place which stop cookies from working. So what we've done is that we've come with a novel idea where we try to understand the browser, the operating system that the user is using, and we try to create a digital identifier or a fingerprint for that particular system. So we don't store anything on the client's browser. We make sure we don't cross that line of privacy, but we still make sure that we track that user across different time spans. And the key thing over here is that from a technical or mathematical point of view, to be able to identify 50 billion visitors, you need a minimum energy of 31, you need an entropy of 31. Like you need 31 different variables to generate a unique fingerprint or a digital identifier for each user. So we use 29, we're still working on getting those 2 more. So we make sure that we try to identify every unique visitor on the internet. And then the yeah. Yeah, the first thing is the browser that you're using, the version that you have, and then the plugins that you have in your browser. And then there are some more finer points like in your browsers, you have WebGL, which actually produces the graphics. So there are some more elements like you can draw things on the canvas in HTML. So what we do is that the thing that you draw on the canvas, the time it takes to draw or the render that particular single line, it depends on the GPU or the graphics card that you have in your system. So we use all these small minor tricks and try to generate a unique thing. And it varies from system to system, model to model.
Does this not reduce the processing time? In the example, I go to a Flipkart.
Yeah.
At the back end, all these processes are going to work, and I'm going to search for a particular thing. So, how much time does it take to create all this?
From what we've noticed is that to generate a unique fingerprint, it takes 21 milliseconds. And we try to defer all these JavaScripts. So that what will happen is that they'll run in parallel and they don't actually stop the user experience that's happening. So it happens in the background.
Thank you.
And the Kafka that I spoke about is that you have lots of data or visitors traffic that is coming in. You don't want all that traffic to hit your database. It's going to be overwhelmed. Like what will happen is that you will only have so much throughput or you'll only have so much IO operations that a system can physically do. So that's why we use this data pipeline where we push all the data into the Kafka, and we have consumers on the other end which try to take this data, they throttle the amount of write operations onto the database and then push it into that analytics engine. And content analytics is something I'll talk about. It's a very novel, unique approach that we've come about. And the visitor interactions and lead identification is very straightforward with what is already there. In case someone visits a specific page, a product page, you call them a lead. It's very simple. And visitor interactions is nothing but using this identifier, we track that particular visitor over a period of time and give you a holistic view when you're trying to approach that particular visitor or customer, or you're pitching something, we try to show what all interactions they have done on your website. So this is the backend that we've used. For website analytics, we built it on top of Cassandra, Apache Cassandra. And then the data we have a Redis on top of Cassandra just to make sure that we don't hit too much on Cassandra. It falls into Redis, and then moves into the Cassandra. And we also perform other transformations like reverse IP lookup. Suppose you are at your company and you're browsing a specific page, like you are the CXO of some department and you are visiting some company's product page. Obviously, you as the website owner, you want to know who that person is, but you only get the IP address at max and probably the digital unique identifier. That would not say much about that. But when you do a reverse IP lookup, that particular IP address would have been associated to that company. Let's say Mirabel Technologies. So you would know that someone was interested from Mirabel Technologies on your product. And then you can go back into our data bank, pull up Mirabel Technologies, try to identify who are the decision makers, and then proactively approach them. This is a unique way you can actually use website analytics. The traditional analytics systems that you have just tells you so many page views, so many visitors from that region, specific region. And that's how we try to identify prospects. They are not leads, they are just prospects you can explore. And then you can have lead triggers, that is visiting a particular product page or a contact page, you can call it as a lead trigger and then convert this prospect into a lead. And then you have this social analytics, where what you can do is that you can key in your competitor's website, and we try to track their social data on what they're doing on the social media and provide you social analytics. Since we cannot dive into his website traffic, we try to give a holistic picture of what's happening on his social media. And next is the content analytics. This is a wonderful feature that we've built for publishers. So what we've done is that we've used machine learning, we've used clustering algorithms and classification, and we've built this piece of feature. So what it does is that once you put in your website, you put in the tracking code, we crawl your entire website. We used naive Bayes classifier. I think you already know that, it's very famous. And we try to classify all the web pages into different topics or segments. And the vocabulary that we used was the IPTC vocabulary. It's the what you call vocabulary that is used by major media organizations or news organizations. So what we do is that we classify the web pages into different segments or topics, and then we try to identify analytics on that specific topic. Suppose you are a major news portal running your online website, you would want to understand which topics are performing good, which are the hot topics. You wouldn't want to see this particular page 1,000 views. You want to understand which topics are performing well right now in the market. And we try to associate that with the trending topics. We crawl the entire internet using our large scale crawlers, and we try to extract what are the current topics or current discussions happening in specific areas, and we try to correlate what's happening in your website with those trending topics and give predictive insights. So we used decision trees at the predictive insights. We actually tell our clients like, you need to focus more on Olympics, or you need to focus more on badminton, because PV Sindhu has won a silver medal and most of your audience are interested in those articles. So we don't just tell the article name, we analyze that and we give a decision that the user or the client can take about and perform some actions. And initial training, we've used the DMOS dataset to train our models and try to identify the new pages that are coming into the system. We've had 60% of that as the training dataset and the other 40% as the testing dataset. And we do a 5-level deep classification, and after classifying everything, we come up with a single point or single statistic called engagement factor. I was talking about earlier, how do you convey this particular engagement to a user? So this is where we've come up with all these statistics. We give a specific number scored on a range of 10. Like, this is the engagement on this particular topic. This is the engagement on these particular areas in your website. So you can focus on that more. And the other ones, I've already talked about the visitor interactions. Yeah. I'll take it after the session, okay? I'm running out of time. Next is the intelligence part. The sales intelligence, we have 4 main things. So this is the architecture that we've used for building the B2B largest data bank. I'll quickly go to the statistics and come back again. We have around 60 million businesses in this data bank, and we've classified those businesses into 24 industries. We've used the North American industrial classification for that. On a deeper level, we classify it into almost 3,000 terms or topics. And we have around 168 million contacts, and we have 8.2 billion data points for these specific data. And we cover data into 18 countries and 3 regions, and we classify every contact into 8 departments like marketing, sales. We try to understand that their particular title, the type of blogs or bios that they write, and try to classify them into 8 departments and 5 levels. The ECSC level, ECA manager, ECA director, we try to classify into 5 levels, so that you can either contact a decision maker or you can go to an influencer if that's your strategy. Yeah. So what we've done is that first we've partnered with VeriSign. We have access to the .com zone file. In case you don't know what that is, any website that's registered on the internet, VeriSign gets a notification. They actually maintain the root level DNS for them. So they have a list of all the .com websites that are there on the internet. So we partnered with them. We took those as the initial seed list. Are you aware of what seed list is? Seed list is nothing but those are the starting websites or URLs that you give to a crawler. It picks up those websites, it goes to that website, finds more URLs or more pages, it crawls onto that. So that is where we started. And then we also take some offline data sources, like lots of governments, they open source or they give out their own companies that are registering. Like India does that, US does that. They have huge list of companies that are registered. So we use that, and we use the same large scale crawler that we built, which crawls those particular files as well, textual files. And then what we do is that we identify that into different parts. Like you have structured data, the data that you get from the government, these Excel files or CSV files, they are very structured. They have columns, they have rows, so you know what sense you can make out of it. And then you have the unstructured data, that's the websites, forums, or blogs that people write about. And then you have semi-structured data, that is the social profiles. You know what first name is, last name is, but it's not properly interconnected. And then you have the news articles, what a company is doing. This basically helps us in classifying what industry a particular company is working about. We as a human can look at a particular company and tell these guys work in retail, these guys work in software industry, these guys are into probably e-commerce, but machines cannot tell that. So we crawl the website, pull out the particular news items, articles, and then we run that into classifiers and then classify that particular company into an industry. And this is the refinery that we built. Basically, there's lots of NLP happening over here. So we use basic NLP analysis for identifying the industries and all, and we use clustering to come up with a particular what you call people. Like you have an about us page where you have lots of profiles. So there we build a cluster. We try to identify if this page is talking about people or not, or is it talking about some PR news article or something. So we use that, and we do link analysis to identify and scrape away links which are not worth crawling. We have lots of white papers, we have lots of contact forms and everything. And then we, at the heart, we have the entity resolution. That is the named entity recognition. Given a sentence like I made her duck, it tries to identify what are the entities. That is, what are the nouns basically. Who are the people, what is the location, address, if anything is there in that particular sentence in English. So we do that. And then we move that into a structured RDBMS, and the raw data is moved into HBase, and on a weekly basis we move it into Glacier Apache, so that we can do, on Amazon Glacier, we can rerun any analysis if we want. And all the semi-structured data like social profiles, everything is moved into Mongo. And then we have a storage cache where we put all the intermediate data that are to be processed more. And on top of that, we have our proprietary search technology. It's been built using Apache Solr, Lucene, and also Graph database. And then you have the actual application on the other side of it, which uses web services to access the big data part of it. So on the prediction side, we have two key parts. First is the content insights. I've already told you, like how we classify websites or web pages into different sections of segments, topics, assign an engagement factor to that, and try to convey to the B2C or any client who is into B2C business as to what they need to do, at what time they need to do, like when are the users active and what is the current trending topics. On the B2B side, we provide sales recommendations. What we do is that we analyze the data in the CRM, we try to identify, we go back to a data bank and pull out more holistic picture of that company. We try to see what areas they are working. We look at their financials. They provide their financials on the internet to the SEC governments and all. We try to see their financials, how their spending pattern is. We try to identify key points, like during the months of August and September, this particular company spends a lot. So that would be the right time to pitch in your product or something as a B2B. So we use a hybrid recommendation system using both collaborative and content filtering. For the descriptions about the companies and all, we use content filtering, and whereas for the data points which are very unique and very straightforward in terms of employee count and revenues, we use the collaborative filtering. And the automation part, we have the CRM, sales assistant, email assistant. This is somewhere we are going. We are still working on the sales assistant and email assistant. That is, you pull up few contacts and you send it to our sales assistant. It automatically emails the person. It tries to put them in a particular loop, and once the person responds, that's when it's going to trigger alert or something to the actual sales rep. So what this will do is that it puts away all the manual labor that you have to do of sending email every day, trying to see if the customer is responding or not. It does all the manual labor, and you just get a trigger or something when he's actually interested, and you can schedule a demo. So for this, again, we've used lots of NLP and NLU in building this. And on the back end for the email, there is lots of machine learning and spam classification and deliverability issues that we've handled. And the team that built this was, we had 5 data engineers who are into both big data and machine learning. And we had 6 backend developers. They are the application developers. And we had 1 UX, 1 program manager, and 2 architects. And we had the other guys. So we've used an approach like microservices. I think most of you would be aware of that, because there are lots of moving parts in this particular product. We've used microservices architecture to build this, so that we could what you call decouple lots of things and try to understand if something fails. And then the front-end application is on .NET and SQL, and the back-end I've already told you, we have NoSQL databases, Java, Scala, Python, C++, and lots of projects from Apache ecosystem. If you have any questions, you can go about now. Yes.
From both structured and
Yes.
unstructured data.
Yeah.
So there is a lot of processing that needs to be done so that you pinpoint a specific name or an organization or some contact information. So how is all of this thing done? So it's not that simple, I would say.
Yes, yes.
So
what we have this data pipeline. You can visualize like you have a data pipeline running. Just think of that. That's the Kafka. You have lots of consumers producers over here. That is the crawlers that are crawling the internet, and crawlers that are crawling the textual files, and they push out into the data pipeline.